Hey, and welcome to this short course which steps you through, I'd like to think, a simple approach to deploying apps with Docker Compose. Without wanting to distract too much from the topic of this short course, if you don't know who I am, I'm Matthew Setter. You might know me better as Setter MJD or the voice of the Free the Gig podcast. I've been writing code in one form or another for about 20 years. The hair might give it away. Most of it has been web-based apps. I do prefer to forget that a long time ago, back in a place called Sydney, I wrote Visual Basic on Microsoft Access. That little joke aside, no offense to people who actually like doing that, I've spent an ever-increasing amount of time over the last 4 to 5 years with Docker, Docker Compose, and containers. And given that investment and my enjoyment of it, I wanted to share what I've learned in a sort of a very condensed way in the hope that I could help you if you are having issues getting started with Docker and specifically Docker Compose. If you're looking for, I guess, as straightforward a way as possible of how do you get up and running locally and then deploy your application to a remote environment, regardless of whether that is, say, a testing, staging, production, or whatever other environment. If you're interested, you can find me on all the socials at webdevwithmatt. You can also find me at webdevwithmatt.com. The site is, at this point in time, as I record this, a little bit of a work in progress, but it's almost finished. Now, what will you learn in this short course? Well, while I can't guarantee what you're going to take away from it, what I hope to impart to you is, in short, this: how to deploy applications using Docker Compose. Just to be clear, it is not a deep dive into Docker Compose. Rather, it covers the foundational information that you need to know. That said, along the way, and there will be accompanying notes with the course, I'll have a lot of information and links so that you can jump off at relevant points and learn more should you find something particularly interesting, particularly intriguing, or just want to know more. Now, more specifically, let's dive down and get a bit more into the nitty-gritty, if you will. You're going to learn how to build a Docker Compose-based local development environment, or said another way, how to Dockerize or containerize an application. You're going to learn how to deploy the application locally or to your local machine. You're going to learn how to build and tag self-contained Docker images, which are required for deployment to a remote environment. Then you're going to learn how to push those images to a remote image registry. That way, no matter where the deployment's made from, the images that make up the deployment, application, are accessible. And finally, you're going to learn how to deploy an application to a remote environment with Docker Compose. For deploying with Docker Compose, to make the most amount of sense, you need to understand really, I think it's fair to say, one key thing, and that is the essence of Docker's architecture. Now, quoting the official docs, Docker uses a client-server architecture. The Docker client talks to the Docker daemon, which does the heavy lifting of building, running, and distributing your containers. The Docker client and daemon can run on the same system, or you can connect a Docker client to a remote Docker daemon. The Docker client and daemon communicate using a REST API over Unix sockets or a network interface. Given that, you can use Docker Compose as your Docker client to deploy to your local machine or a remote host, or as part of a workflow tool such as GitHub Actions. Now, because of that, no extra commands such as Docker Swarm mode or Kubernetes are required. To be fair, there are more advanced ways to deploy applications with Docker than I'll be covering in this short course, and Docker Compose was only designed for deploying to a single host. But depending on the requirements of your application, this approach may be all that you need. The main thing to keep in mind is which Docker daemon is your Docker client connecting to. So, what are you going to need to follow along? Well, honestly, not that much. Just the following things. Firstly, a broad understanding or familiarity with Docker, such as terms like image, container, and service. I guess I should have said broad understanding or familiarity with sort of containers and containerization, but allow me, if you will, a little bit of Docker-specific terminology because we're talking about deploying with Docker Compose. Next, you'll need Docker Engine or Docker Desktop. After that, you'll need, naturally, Docker Compose. Now, it does come with Docker Desktop, but I believe not with Docker Engine. Call me out if I'm wrong, though. After that, you'll need access to an image registry, such as Docker Hub or DigitalOcean's container registry, and finally, a deployment server running, naturally, Docker. So, with that out of the way, let's talk about the demo application that I'll use throughout the course. It's a small one which uses PHP's Mezio framework. Now, if you don't use PHP, feel free to substitute in your preferred development language. However, as I reference PHP a little bit intermittently throughout the course. Anyway, that said, as you can see here, here's what it looks like in all its glory. If you're not really sure as to what exactly is going on, who these people are, or what Hawaii 5.0 is, it lists the main cast of Hawaii 5.0 from the 2010 to 2020 reboot. And you can see it shows the actors' profile pictures, names, and character names. It's not that sophisticated an application, rather a simplistic one that reads records from a MySQL database and then just renders them. It doesn't make use of any logging, queuing, or caching servers. Now, I've deliberately kept the application simple because I don't want it to distract from the purpose of this course, which is to talk about deploying the application, not how is the application built, how is it architected, and so forth. And if you haven't checked out Hawaii 5.0, I strongly recommend that you do because I'm a huge fan. I've got the box set. It's amazing. And what's more, the main actor or lead actor is an Australian, so just like me, what is not to love? Anyway, but seriously, digging deeper, the application will need 3 services for it to function. A PHP runtime, a web server to serve the static content, and a database to provide the dynamic information. Again, and I guess just for one last time, if you don't use PHP, maybe you use Go, Ruby, Python, whatnot, just substitute that in. Now, this composition of the application nicely follows the Docker ethos of one process or service per container. So, with that said, now let's work through the core files that you're going to need to configure Docker Compose with. I usually use, as you can see here, a somewhat simplistic file and directory structure. One located in the root directory of a given project in a directory which I think is aptly named Docker. Now, I don't have a special reason for this, other than it was what I noticed other people seemed to use when I was getting started and over the course of time, and that it worked for me. This top-level directory is then subdivided into directories for the services within the application's configuration. Then, within each of the service directories is a Dockerfile containing the instructions for building the underlying image for that service. And we'll see those throughout the course of this short course. Now, alongside the Dockerfile are any supporting files for that service's image. Now, as a little bit of reflection, I used to have a separate Dockerfile per environment, but I'm now using one Dockerfile for all environments by taking advantage of multi-stage builds. The main reason for that is I find it, at least for myself, just easier to maintain, easier to reason with, and simpler to debug. Now, finally, there is a base Docker Compose file which contains the configuration that is applicable to every environment, along with a Docker Compose file for each environment. Now, these contain a combination of additional settings and overrides to existing settings. I've found, personally, you may differ, but for me, this approach makes a Docker Compose configuration easier to create and to maintain. Now, let's start working through the Docker files for each of the relevant services. I'll start off with the PHP service. It starts off with the from instruction, which bases this image on the official Docker Hub PHP image, the one that uses PHP FPM 8.1.1, which itself is based on Alpine Linux. Now note that it adds the string as development at the end of the instruction. This enables the first of two stages in a multi-stage build, this one being only for use during development. If you're not familiar with multi-stage builds, the official documentation, as you can see here, says with multi-stage builds, you use multiple from instructions or statements in your Docker file. Multi-stage builds have many advantages, such as making it easier to build a Docker file that supports multiple environments with one file instead of splitting a configuration across multiple files. Again, I just find having one file just is easier for me to sort of reason with and just takes less time to find what's going on. Though some colleagues and friends have said that they find the opposite to be true. Now, each from instruction can use a different base image, and each of them begins a new stage of the build. Because of this, you have quite a bit of flexibility and power, such as being able to selectively copy artifacts from one stage to another, yet leave behind anything that you don't need in any subsequent stages and the resultant final image. While multi-stage builds can add complexity to the build process, when done well, they can both simplify the build process and, which is pretty cool, reduce the final image's size, and that can play nicely into your hosting costs, your deployment time being reduced, and a number of other benefits. Now, next up comes the run instruction, which installs, in this case, the PDO MySQL extension. That's because without it, PHP can't interact with a MySQL database. Then it installs and enables Xdebug for step-through debugging. Now, you might be kind of wondering why I've not done other things. Well, the main reason for that is there's only so much you can fit on a slide, so I've not added other common development options just for the sake of space. And I like simpler presentations. I don't like to ram in every possible thing that you possibly could need just in case you might want to see it. So just imagine, if you will, that you've got all the other options that you would likely use there. Now, let's step through the second stage. Again, based on the same base image as the first, but this time named production, because the base or the from instruction ends with as production. It then installs the PDO MySQL extension as well. It then sets the working directory or the base path within the image where subsequent instructions operate relative to, if relative paths are used. After that, it copies over all of the app source files into /var/www/html. And finally, it mounts version 2.2.7 of the official Docker Hub Composer image, which is PHP's dependency manager. If you're not familiar with it, it makes /user/bin/composer in that image available to /user/bin/composer in this image or this stage. Then it runs composer install to install all of the dependencies listed in composer.json, which was copied into the image where the dependencies are defined. Now, before I move on to the database's Dockerfile, I just want to cover a few little multi-stage build time-saving tips. Each of the two stages in this Dockerfile started off using the same base image. That's fine, but as with code, doing so can lead to errors if one or more from instructions aren't updated when switching to a new version, for example, such as a new version of PHP or a newer version of Alpine Linux. So instead of explicitly naming the base image in each stage, as I've done here, You could use some Dockerfile arguments, such as in this example. Here, the PHP and Alpine Linux version strings have been defined as arguments, which are then used in the from directive. That way, if one or more versions change, you only need to change the arguments, and each stage that uses them is automatically changed for you. Now, you could also set them in the Docker Compose file, as I'll cover a little bit later on, which could be helpful when working with multiple versions of PHP or your language runtime of choice, for example, or whatever language you're most familiar with. Now, in addition, you could use one stage as an alias, as stages don't need to contain any instructions. By doing that, as I have here, each subsequent stage can be based on that stage, resulting in a shorter name, making the file easier to intuit and to maintain. Just something for what it's worth that I've started doing over the last couple of months and have found works really nicely. Now, let's get back to it and look at the databases Dockerfile. The reason for this Dockerfile is to simplify creating the database schema and loading data into the database inside the image. That way, when the application is deployed, the database is ready to go. Now, naturally, as I'm sure you're aware, there are a host of ways that you could do this. And in all likelihood, you'd probably, I guess, use a professional database hosting service such as DigitalOcean's Databases Service, ScaleGrid, or Heroku, perhaps in tandem with a migration tool. But for simplicity's sake, we're going to do it this way. Now, the copy instruction copies a SQL file, which we'll cover in just a moment, into the /docker entry point initdb.d directory inside the image. This is because the MySQL image, when it's created, if it finds a .sh, .sql, .sql.gz, or .sql.xz file in that directory, will run it. So here's the SQL file, or well, should I say here's a part of it. As you can see, it's a reasonably small file which I created using MySQL dump, which contains part of the instructions to create the database schema. It also inserts a set of records into the table once it's been created. And you can see here some fake email addresses that I made up just for testing purposes, along with the first name and last name and the ID of the characters. Now, with the Dockerfiles and their supporting files ready, let's now work through the Docker Compose files. Starting off with docker-compose.yml, which is Docker Compose's primary configuration file. The configuration starts by setting up a persistable file system volume, which is used by the database container. Now, this is important because while file systems in Docker containers are writable, they don't persist changes across container restarts. This is because when a container is started, it uses the specified image at the time that the image was created. Naturally, that image won't have any new files that will be created by our application, nor will it have any changes to existing files. This isn't that great, as I'm sure you'll note, when working with databases or other storage mechanisms. Hence, why we're creating a persistable volume where any new files and changes to any existing files will be kept across container restarts. We next defined an element called services. This element, which I've split up over a number of slides as it's far too long for one, lists the definitions of the three services or containers which make up the application. It starts off with the NGINX container. Given that it's named NGINX, the container will have a matching hostname of NGINX. Note that it doesn't contain an image option to specify a base image to use or a build option to tell it where to get its build instructions from. These will be specified in the environment-specific Docker Compose file. Next, it sets the restart directive to unless stopped. By doing this, Docker Compose will restart the container if it should crash or stop for some reason other than when it's intentionally stopped by running Docker Compose down. One thing worth noting though is the ampersand restart policy before the value unless stopped. This isn't Docker Compose specific. This is a YAML anchor, and it helps you avoid repeating yourself. In this case, what's happening is that an anchor to the value has been created, which later services will reference, so that they all use the same value without hard coding it multiple times. The restart directive supports 4 values. These are no, which means that Docker does not restart a container for any reason. Please note though, unlike the other 3 options, which I'll step through, no has to be double quoted if you use it. I think it's something to do with the Docker Compose YAML parser. It's something that some colleagues have pointed out to me. I never came across it because I don't actually use that option much, but just be aware of that. The next option is always, where Docker will always restart a container if it stops. If it's manually stopped, it's restarted only when the Docker daemon restarts or the container itself is manually restarted. Then there's on failure, where Docker will restart a container if the exit code indicates an on failure error, and unless stopped, which we've gone through. Now, next up, the depends on option creates a dependency between this service and the PHP service, which we'll define shortly. In short, it means the NGINX service won't start until the PHP service has started. Now, the last configuration for this container is to add a health check. Now, these determine if a container is considered healthy or needs to be restarted. Gladly, and I think it's kind of cool, health checks can be whatever we want them to be. In the case of Mezio applications, they come with a ping endpoint, which I guess is similar to many other frameworks, which will return a JSON response containing the current timestamp. So I think this is a nice, if simplistic, way of testing whether the application is still working. So, stepping through what that means a piece at a time. The health check will make up to 3 curl requests to that endpoint every 60 seconds, allowing for a 3-second timeout. If 3 attempts to the endpoint fail, the container will be considered unhealthy and be restarted. The configuration for the PHP container is similar-ish to that of the NGINX container. You can see it starts by naming the service PHP. It's then set to restart if it should stop, unless we stop it, by referencing the YAML Anchor restart policy in the NGINX service. And now for the database service. As with the other containers or services, we've given it a name and it's set to always restart unless stopped. This time we're using the build directive to tell it to use the Dockerfile located in docker/database, which we stepped through before, to use for its build instructions. Now let's create a Docker Compose file for the development environment. As I mentioned earlier, this will contain additional directives relevant to this environment and overrides for existing settings that were set in docker-compose.yml. Okay, technically docker-compose.yml, but it's just a bit easier for me to say docker-compose.yml if you're feeling a little bit nitpicky. First, it uses the image option to tell it the base image to use, specifically the latest version of the official Docker Hub NGINX image. I deliberately put that in there because I kind of wanted to draw attention to the fact that you really shouldn't use latest images. The reason for that is that if you do that, it will always, what would you say? It's perhaps a good way to describe it is it's a rolling release. So if you base your application on that, you may end up with application breaks because some of the binaries, some of the versions change. What is better to do is to pick a specific tag, such as I did earlier, where I used, was it PHP 8.1.1 FPM with a specific version of Alpine Linux. So that might seem a weird way of expressing a point, but please allow my perhaps quirky style. Anyway, then it uses the ports option to map port 80 in the service to port 8080 on the host machine. Then the custom NGINX configuration file, which we'll see next, is copied into the image in place of the default version. After that, the current directory on the host machine is mounted inside the container at /var/www/html. Now this lets us develop locally on our host machine, yet have the code be accessible to the NGINX container. You could say it has the effect of sharing the local directory with the container, rather like Vagrant shared folders, for example. When you make a change in your development environment, the changes are available in the container as well. Pretty much straight away. I think there's like an ever so slight sync delay. That said, there's no need to manually copy or sync files between your development environment and the container. Now here's the NGINX configuration file, or most of it. It isn't all that special. However, it extends the default NGINX configuration to send all requests to /public/index.php and then pass off PHP requests to the PHP service on port 9000. Now, let's step through the PHP service. The build directive, through the context and Dockerfile subdirectives, tells it to use the Dockerfile located in docker/php, which we stepped through before for its build instructions. By adding the target subdirective, we're telling it to use the stage named development, skipping all other stages. Now, if we didn't specify this, it would execute from the first through to the last stage. Then, as with the NGINX service, it maps the local directory on a development machine to /var/www/html in the service. Finally, let's look at the changes for the database service. First, it sets the environment option. Here, we can pass environment variables to the container. We're setting 3 in this case. These are for the database user's username and password and the database name. Now, if you're interested, you can find a list of the predefined environment variables for the MySQL image in the image's official documentation, and that holds true, I believe, for at least all of the official Docker Hub images. Then, using the volumes directive, we're making any changes in /var/lib/mysql, where MySQL stores its data files permanent, as they'll be written to the persistable file system volume. And finally, it maps port 3306, the standard MySQL port in the container, to port 3306 on the host machine. That way, GUI tools such as the MySQL client or DataGrip or whatever it is that you prefer to use could be used to administer it. Right, now that we've finished the Docker Compose configuration, let's deploy the application locally. I appreciate it's been a bit of work up until this point, but we are moving rapidly through this. To do that, I'll call docker compose up, and to the command, I'll pass the file option twice, once for each Docker Compose file. However, what's really cool, and a little extra thing I'd just like to share, is that you don't always need to specify configuration files, depending on how you name them. The reason for that is that, as I mentioned already, Docker puts the defaults in docker-compose.yml. But you can also make use of a supplementary file that Docker will look for if present, called docker-compose.override.yml. As the name implies, if that file is present, Docker will then supplement docker-compose.yml and also override any settings that that file contains. So let's assume that you're following the process or the file and directory structure that I've outlined so far. You put the core or the base definitions and settings in docker-compose.yml, and then you have an environment-specific file such as docker-compose.dev and .prod.yml, where you store the development and production settings and overrides respectively. Well, assuming that you're using a Linux or Unix-based system, because I don't believe that Windows supports symlinks, what you could then do is symlink docker-compose.override.yml to the respective environment-specific file, such as docker-compose.dev.yml, as you can see in this example. Because you've done that, you now don't have to pass the file or shorter F option when you run Docker Compose up, as you can see here, because Docker will then see that the files are present, that being docker-compose.yml and docker-compose.override.yml, and use them implicitly. Now, as you can see here, after the command runs, you can see each container being created and started. Now, this may take a few minutes based on the speed of your connection. However, on any subsequent call to Docker Compose up, it'll usually start up in under a minute. If the base images which we're using haven't been downloaded before, then Docker Compose will pull them down first and then run the instructions in the respective Docker files to create the custom images from them. And then they'll be used to launch their respective containers. At this point, the log files for each one will be printed to the terminal, as you can see happening here. Now, the reason that I do this, at least the first few times as I'm setting up a new configuration, is so that I can see in the terminal output if anything didn't work. If that's the case, I then press Ctrl-C to stop the application, or to undeploy the application, if you will, address the issues, and then start it up again, and do this repeatedly until the application is at least not showing anything in the log output to indicate that something's going wrong. Now, if you want to save yourself a bit of time, pull the respective base images down locally first, using Docker pull, as you can see in these examples. Now, getting back to our application, if everything works, if there's nothing in the log files to say that something's gone wrong, you then start it up again, only this time using, as I do here, the D option, or you could also use the longer detach option. Now, when either of these options are passed, after the containers start, Docker goes into detach mode, where the containers are run in the background. But because of that, the logs aren't printed to the terminal. However, it's still handy to check if everything's working as expected. To do this, you can use a combination of two Docker commands, should I say Docker Compose commands, those being Docker Compose PS and Docker Compose logs. Now, the Docker Compose PS command is analogous to Linux's PS command, if you're familiar with it, which displays process status information. Now, if you were to run it, as you can see I've done here, it will show a list of the containers in this particular configuration, including their name, state, and ports. This way, we can quickly see if all of the containers are up and running, or if there's a problem with one or more of them. If you want to get the status of just one container, however, or maybe a few, just anything less than all of the containers in your configuration, then add their names to the end of the command, as I've done here, where I'm just going to filter down on the database container. And when that happens, it will then filter down the logs that are output to the screen to just that container, or those containers if you're filtering on multiple. Just worth noting there, I should have said that add their names space separated at the end of the Docker Compose PS command. Now, let's assume that Docker Compose PS showed that the database container had exited prematurely, so we want to learn why. Well, to do that, I guess sort of similar to before, we'd view the logs for that container, but this time using the Docker Compose logs command, as you can see here. And by passing the follow option, it'll tail the logs until we press Ctrl-C. I guess it's similar to the tail command in Linux. Now, as before with the Docker Compose PS command, if you want to view the logs for all containers, just don't filter by one or more containers. If you do want to filter down, just pass the container names, space separated, to the end of the command. Now at this point, the application is running because there are no errors, no problems. So if we were to open localhost on port 8080 in our browser of choice, such as Firefox, which you can see here, you can see that the application is running in all its glory. Now that we've made the deployment to the local machine, let's have a quick recap of what we've achieved. Firstly, we've created a directory structure to store the Docker files that we need, along with any supporting files. What's more, it's nicely structured around environments. This way, if we wanted to, we could add more environments later, building on that existing structure. Next, we created Docker files for each of the 3 services that compose the application, which were later used to create the images which Docker Compose used to launch containers with. We based each image on an existing base image so that we only had to do as little as possible, yet gaining a lot of functionality right out of the proverbial box. We then created a 3-service Docker Compose configuration with a combination of a broad base Docker Compose file, which was complemented by an environment-specific one. The configuration file used the Dockerfiles, which we created, one that supported health checks so that it would know if a service was ready or not, which synced the source files to the running container, yet which let us work locally without having to copy over files when we'd change them. We set environment variables, configured the services to auto restart if they crashed, and made the database service available to local database tools. Then we learned how to start or deploy the application locally using a single command, and we learned how to do some basic status checking and debugging should something go wrong. Now, while there is much more, so much more that we could learn, this is still already a lot of progress. So let's now move on and see how to build on this foundation by creating the production files and round out this short course by making a production or remote deployment. The first thing that we're going to do is create a Dockerfile for the NGINX service. Now, the reason for this is that it wasn't necessary up until now, as the NGINX service in the development environment used the official Docker Hub NGINX image with no special changes, but for production, that's not going to work. The Dockerfile uses the latest version of the official Docker Hub NGINX image, specifically the Alpine Linux version. Again, it's always best to use a specific tag so that way your environment doesn't sort of change out from underneath you at some later point when that latest version is changed. It then sets the base path where subsequent instructions operate relative to, that being to/var/www/html. Next, 2 copy instructions are used to copy the custom NGINX configuration file, which we saw earlier, into the image inside /etc/nginx/conf.d and the contents of the current working directory, that being all of the application source, configuration, and related files, into the image inside /var/www/html. Then, using Alpine's package manager, APK, it is amazing, it's cool, it's wonderful. It installs the required binaries that the image will need, then runs npm install to install the front-end dependencies. Now, with everything in place, it finishes up by running npx and Tailwind CSS to build the application style sheet from the base configuration, instead of generating a sizable development version. If you're familiar with Tailwind CSS, the development version would be around 4.2 or 4.6 meg, whereas this version should be something around about, 23k. Anyway, just a little bit of side trivia there. Getting back to the specifics here, the generated style sheet will only contain the required CSS properties, and after it's built, will then be further minified. This way, the file in production will be as small as possible and be generated only when required. That way, 2 copies don't have to be stored under version control. Now, as we've been going through this, if you're not familiar with NPX or Tailwind CSS, that's fine. The reason why I covered this was to try and give it a quasi-real feel to it, so that it felt like, as much as is practically possible, a real version, a real configuration that you use. So please sort of don't be concerned if you're not familiar with these tools, and sort of swap in mentally what you might use if it were your application that you were building. Now, what we need to do now is to create the production Docker Compose configuration file. It'll have the same services with largely the same configuration for each one. However, there are a few differences to pay attention to. The NGINX service now uses the NGINX image, which we'll create in the next section. Also, instead of mapping port 80 in the NGINX image to port 8080 on the host, it's mapped to port 8080 as that's the default web port. And similar to the NGINX service, the PHP service uses the image, which we'll create shortly. We could and likely would add in other options here, but I haven't, just for the sakes of simplicity. Now for the database service, similar to the other two services, it uses the database image, which we'll create shortly. Secondly, we're not explicitly setting the environment variables this time. Instead, because of this specific configuration where you don't see them being assigned a value, they'll be retrieved from the environment where Docker Compose is run. Now, as I'm sure you're fully aware, but I feel it's just worth reiterating, there are a number of ways to set environment variables, but again, for sakes of simplicity, let's assume that we're using Linux's export command and we've run this before we would run Docker Compose up in this environment. So now that the Docker files have been created, it's time to build the images from them and push the images to the remote image repository. To do that, you'd use the docker build command, as you can see here. Now note the options supplied to the command. Firstly, there's a file option, but we could also use the short F option, and this provides the name and path of the Docker file containing the build instructions. I'm doing this as the Docker file is not located in the directory where I'm running the command from. Next up is the path to the image's context, which is the dot or period or full stop at the end of the command. All the commands will run relative to that directory. And finally, there's the tag option, and we could also use the shorter T option. This tags the image. Now there are a couple of things to note with this option. Note that the tag's label starts with web dev with Matt, which is my Docker Hub username. Actually, it's one of two. By doing this, when the images are pushed, this information doesn't need to be specified, as it will automatically be retrieved from the image. We could also supply a Docker Registry URL if we were using a service other than Docker Hub as well, but since I don't need to. But if you're using another service such as I think GitLab or DigitalOcean's container registry, you would have to pass that in. I'll have some notes on that in the description for this course. Now, we've also given the image a name and a tag. Note the tag I've been kind of pushing throughout the course so far. Well, we can call these what we want, so long as they're unique in our account. But it's always helpful just to have something that is meaningful, something that is practical. Now, regardless of what you name it, what you call it, what your username is, and all that stuff, once the images have been built, we can confirm that the images are ready. And we do that by using the docker images command. Here, we see the repository and tag names and that it was created just a little while ago. If you have a long list of images, which if you've been using Docker and Docker Compose for any length of time, or if you're working on multiple projects, or you're a freelancer working for multiple clients, or at an agency and you work for multiple customers or clients, then it's likely that you may have a very, very long list. So in that case, I just want to quickly encourage you to use the filter option to filter the output to just the images that you're interested in, as I have here. With the images built and tagged, it is time to store them or push them to an image registry. That way, they're accessible no matter where the deployment is run from, no matter who or what makes it. For the purposes of this short course, as I've kind of hinted at up to this point, I'm using Docker Hub because I thought it would just be simpler to do that for sakes of simplicity. However, if you prefer, you can set up a local Docker image registry using Docker Registry, a fantastic open source package, or you could use a different service, which I've hinted at, such as DigitalOcean's container registry. Now, I mentioned DigitalOcean a little bit throughout this short course. Just want to say, complete transparency, they are not promoting or sponsoring this short course in any way. I'm just mentioning them because DigitalOcean is the service that I'm most familiar with. So I'm kind of most comfortable using references of and talking about. But if you use another service, kind of just swap that in. Now, as you might expect, given the commands that we've used so far, we're going to use docker push to push the images to the image registry. But naturally, before we can do that, we have to authenticate. So we'd call docker login, first passing the relevant credentials. After that, as we're authenticated, we can push the images, as I'll do here, using docker push. Now, we've done most of the work, and believe it or not, we're just about done and just about ready to make a production or remote deployment. But before we deploy the application to production, I feel at least, it's good to test that it works locally. And that's kind of another cool thing about Docker and Docker Compose. So we can do this as before using Docker Compose up. But this time, the only difference, and I guess it's something really worth reiterating, is that we just changed the Docker Compose files that we use. But this time, we use the default Docker Compose file, but the production Docker Compose override file instead of the development version. Then, when the terminal's output stops scrolling, I'll check that it's working by running Docker Compose PS again, but using the production configuration file. If all of the container states are listed as up, which they are here, I think we can be pretty sure that the deployment will work. If, however, one of the container's status columns is listed as starting, just give it a little bit longer and then check again for the health check to complete. Otherwise, if one or more of the containers is not working, then as we stepped through previously, check the logs using Docker Compose logs with the F option to see what's wrong, correct that, and come back and try again. Now let's assume that the local deployment of the production version of our application was a success. We'd now use Docker Compose down, as I will here, to stop the application, as we no longer need it running. So, given that, it's now time to finally, if you will, deploy to production or any other remote environment. But before we can do that, I'm sorry to kind of feel like I was really getting going just to say but it needs to be said. We have to tell the local Docker client to use the Docker daemon running on the remote host. To do that, we can approach it in one of three ways. Specifically, we can set the docker_host environment variable before running a Docker command or with the command. We can use the capital H or host options when running a command. Or, as has sort of pretty much become my preference, we'd use a Docker context and then run Docker commands as normal. Now you can see here a set of examples of using the Docker host environment variable or the H or host options. Each of them specifies the Docker daemon to connect to. While I found this helpful in building a GitHub action-based workflow for running commands locally, I've kind of honestly found it a bit frustrating. The main reason is maybe I'm just getting a bit older. I'm mid-40s now. Maybe I'm just a bit forgetful, but at least at some times, I have periodically forgotten to set it or to set it consistently, or I've set it incorrectly. And that has led to some frustrating debugging sessions and some mixed results, let's just say that. So at least so far, when running it locally, I do recommend using the Docker context command. So to give a little bit more information, if you're not familiar with the term Docker context, here's what the docs say. It says that a single Docker CLI can have multiple contexts. Each context contains all of the endpoint and security information required to manage a different cluster or node. The Docker context command makes it easy to configure these contexts and switch between them. Perhaps a simpler, less, what would you say, jargon-laden way of describing it is it's a way of telling your Docker client which Docker daemon to connect to, along with all the relevant details that it needs to connect to that daemon. To boil that down, by default, there's a Docker context named default, kind of a handy name, that references the Docker daemon on your local machine. So by using the Docker context set of commands, which we'll step through in just a sec, you can add any number of additional ones that you can then swap between, which is handy if you're deploying or working with multiple environments. So when working with contexts, you generally only need to do two things. That being 1, create a context, 2, set it as the default. Then you can run your Docker commands as you normally would. So let's do that now and create a Docker context to the remote host. So you can see here that I'm going to create a new context called remote, a very kind of unintuitive name because remote could be anything. I perhaps should have called it production. I'm going to connect over SSH. I'm going to use the username of deploy, and then I'll pass in the domain name of the remote host. In short, what I've done is created a new context named remote, and then what I'm going to do after that is use the docker context use command and pass in the name of the new context, that being remote, so that now not only have I created a context in addition to the local one, but I've now set it as the new or the active context, so that any Docker command I run after this or from this point onwards will connect to that Docker daemon and not the local machine. You might note that I'm a bit of a stickler for checking things, a little bit pedantic perhaps, but I find it helps. And it's also a good way to introduce just one last command, which is docker context ls. This can be helpful if you have a series of contexts and perhaps you're just not sure which one you're using, which one is active. So if we run it, as you can see here, you'll then see in the output to the terminal the list of available contexts with an asterisk in the name column after the name of the currently active context. So that way you know which one or which remote Docker daemon your local Docker client is connecting to. All right, so with all that done, no more messing about, we are now ready to deploy the application to the remote environment. To do that, as we did with the local deployment, with the test of the production deployment, we run docker compose up with the D option. You pass in the file or short F option if you wanted to specify the files, but not in this case because we've symlinked the production file to the override file, and that's it. That's all we have to do differently, because as we just created and enabled a Docker context, the Docker client will interact with the remote Docker daemon, not the local one. And now that it's running, as with running Docker Compose in development, you can see that the containers are starting, but this time on the remote Docker daemon. Honestly, I think that's really cool because you use the same set of commands regardless of where you're working and where the deployment is being made to. One thing's worth bearing in mind, and that is that it may take a bit of time for the remote host to download the images from Docker Hub in this case, or if you're using another image registry. But that's just normal because if it doesn't have them, then it needs to get them first before it can use them. But after that, on any subsequent deployment, it should start up reasonably quickly. So, did it work? Yes. Testing again. With the deployment now made, let's just check that it worked and kind of bathe in the coolness of using the same commands but them transparently connecting to a remote daemon instead of working with the local one. Because we've created a context and set it as the active one, then as before it, as we did previously, we use docker compose ps, and we see that everything worked quite nicely. If, however, it wasn't working, again, as before, and I kind of feel like I'm laboring this point, it may be unnecessarily, but it's kind of cool anyway. We use docker compose logs and the other relevant Docker commands to check out what's going wrong. But otherwise, you'll see the output as before. It may as well be kind of running locally, but that's all you need to do to deploy to your production environment, testing, staging, or wherever you need to deploy your application. And that's it. So let's recap what we've learned in this second section of the course. You learned several key things. 1, how to build application images. 2, how to store images or push images to a remote accessible image registry. 3, how to tell the Docker client which daemon to communicate with. 4, how to build a deployment configuration and how to deploy the application to a remote host. While there were many new things to learn about, you are now ready, I assure you, you are, to deploy your application to any remote environment, or you could say kind of remote daemon, of your choosing, while staying within a core small set of Docker commands and within the larger Docker ecosystem. Now, if you'd like to dive deeper into the topic, then I fully encourage you to grab a copy of my free book called Deploy with Docker Compose. You can find it at deploywithdockercompose.com. It covers the topic in a lot more detail than I've been able to in this short course, yet without going overboard. It's packed with tips, tricks, and pointers that I've learned along the way. If you're interested, you can download a copy for free from deploywithdockercompose.com in return for your email address. Anyway, thank you very, very much. I hope you got a lot out of this. I hope you enjoyed it. I hope it's been something that has helped you if you've been maybe having a bit of a struggle with Docker and specifically Docker Compose. I hope that it has shown you that really there are only a small set of commands that in essence you need. I appreciate that different applications have different requirements and that the rather simplistic approach I've taken in this short course may not quite be what you need, but it also may be. Thanks very much for watching. If you'd like to know anything more, check out the notes for this short course. I hope I didn't go too overboard. They are reasonably lengthy, but they give all the relevant information that you need should you want to jump off to any other points of interest, dive deeper into a specific topic. And otherwise, I would love to know what you think. Please share your thoughts in the comments. Give it a thumbs up if you liked it. And I will see you in future videos and future short courses. I'll see you later.